Hey everybody, welcome to 1994 AB number 3 here on implicit differentiation. This is Nicholas JMV. I'm excited to go over this particular example with you. There are 3 parts here. No calculators allowed. We don't need one. You can see I just kind of have the information. This was taken, I use this as general for the AP classroom instructions here. Free response, no calculator. So let's go ahead and get started. So I rewrote this one. I was starting to do this one by hand and my microphone messed up, so please forgive me. So consider the curve defined by x squared plus xy plus y squared equals 27. And we have to write an expression for the slope. So we need the derivative. So we're going to take the derivative of this function. And remember, because it's implicit, what we really need to do is when we take the derivative with respect to y, make sure you multiply by y prime. So I've got my equation written here. Let's go ahead and take the derivative. The derivative of x squared is 2x plus, we have a product rule here, so first times the derivative of y, which is 1, or y prime, plus second times derivative of x, the first function, which is 1, plus the derivative of y squared is 2y, but since we're taking the derivative of a term with y, make sure you multiply that by y prime. The derivative of any constant is 0. So we're lucky here because we got both of our y prime terms here and here on the same side. So that means we got to get rid of x and we got to get rid of y. We're going to move that over to the other side. So you can see I'm going to be left with x y prime plus plus 2y times y prime equals negative 2x minus y. I went ahead and brought those other two terms over. And because both my terms just have a y prime, I'm going to go ahead and factor that out now. And I'm going to be left with x plus 2y in parentheses because I'm factoring out the y prime out of both terms on the left side. And that's going to be equal to negative 2x minus y. The final step here is just dividing each side by the x plus 2y. So my derivative y prime, or dy dx, is going to be negative 2x minus y all over x plus 2y. And there's our derivative. We'll come back to that in a little bit. So that's the first part of this. Now this is a 3-part problem. FRQ questions give you 15 minutes per question on the exam, so you're getting roughly 5 minutes per part here. So in part B, it's asking us to determine whether the lines tangent to the curve at the x-intercepts are parallel. So we want to know parallel curve, we want to know at the x-intercepts lines tangent, are the slopes equal? That's what we're asking for there. If we have the x-intercepts, what are the slopes there? And if we know the slopes, are they parallel? Are they the same? If we know the slopes are the same, the lines are parallel at those points. So we're talking about the x-intercepts here, so y is going to be 0. And so we're going to go actually back to our original function, and we are going to go ahead and find the x-intercepts first. Then we're going to use our derivative to see what their slopes are at those x-intercepts. So we're going to set y equal to 0 to our original equation. So anything with a y in it is going to go to 0 because y has to equal 0 for x-intercepts. So we're only left with x squared equals 27 because xy goes to 0 and y squared goes to 0. So here x is going to equal plus or minus root 27. Now that simplifies into plus or minus 3 root 3. But I'm going to use this. I'm going to keep it simple. So my x-intercepts are root 27 comma 0 and negative root 27 comma 0. Those are my x-intercepts. So what I need to do now is find the slopes at each of those points. And so we're going to use our derivative. We know our derivative is equal to y prime, or y prime is equal to negative 2x minus y over x plus 2y. So wherever x is, we're putting root 27, and wherever y is, we're putting 0. So we have negative 2 times the square root of 27 minus 0 over root 27 plus 2 times 0, which gives me negative 2 root 27 over root 27, which gives me negative 2. So the slope of the tangent line at root 27, 0 is negative 2. Let's see if it works out for the other one. So now we're going to plug in negative root 27. So we're going to have negative 2 times negative root 27 minus 0 over negative root 27 plus 2 times 0. Now the numerator becomes 2 root 27. Now that's different than the other one, but our denominator is negative now. So you get negative 2 as well. So because those slopes are 0, or excuse me, because those slopes are negative 2, the same, we know that the x-intercepts are parallel. So how do we want to say it? We could say the lines tangent to the curve at the x-intercepts, and you could do plus or minus root 27 comma 0, are parallel because their slopes equal. And that's good enough for that problem. We've found the x-intercepts, we found their slopes match, therefore the lines tangent at those intercepts are parallel. In part C, we are going to find the points on the curve where the lines tangent to the curve are vertical. Now, we know our derivative is a fraction here, right? And we know that our horizontal or our tangent lines, have to be vertical. That means they have to be undefined. And the only way to make a fraction undefined is dividing by 0. So we're going to set x plus 2y equals 0. And in this case, we're going to know that y is going to be equal to negative x over 2. So solve that equation for y. Now we want to find the points. So we're actually going to be using the original function just like we did in part B. But in this case, wherever there's a y, we're going to go ahead and substitute a y in. Our negative x over 2. So we have x squared plus x times negative x over 2 plus negative x over 2 squared, and that equals 27. So there's our original equation. We get x squared minus x squared over 2 plus x squared over 4, and that equals 27. So I squared it out. I cleaned it up a little bit. I multiplied the x out. And we need a common denominator on the left. We have 1, 2, and a 4. Common denominator is 4. So we get 4x squared minus 2x squared plus x squared all over 4. And that's equal to 27. Simplifying the numerator, 4 minus 2 is 2, 2 plus 1 is 3. We have 3x squared over 4 equals 27. Okay? We can now cross multiply, which gives us 27 times 4, which is 108. And we get 3x squared. If you divide by 3 and take the square root, I believe you get x equals plus or minus 6. So now we have the x values of where our curve is going to be a slope where our curve is undefined, excuse me. So we know that y equals 6 over 2, and that's negative, which is negative 3, or y equals negative 6 over 3, which is positive 3, or 2, excuse me, here. So our 2 points are 6, comma, negative 3, and negative 6, comma, 3. Those are the 2 points where our lines tangent to the curve are vertical, where they're undefined. So that wraps up FRQ number 2 for this series, 1994 AB3 on implicit differentiation. So if you have any questions or comments, please feel free to type them below. I hope this video helped, and we'll see you next time.